Hello everyone, I am Bradley Sward, Associate Professor of Computer and Information Science at the College of DuPage in Glen Ellen, Illinois, and this video is going to look at Day 10 festivities of the Advent of Code 2020, and I'm, as always so far, doing everything in Python. So here is the adapter array problem. There are basically a whole ton of, this is the data set here, a whole ton of numbers, which are the joltages that I'm allowed to handle with my adapters. And basically I'm allowed to go from 0 or 1 to 3 difference between them to be able to work my way up the chain to figure out basically kind of in a way like what is the largest number. Or I guess the problem is I want to find a way to use every one of my adapters. And so when I do that, how many, so the question asks how many 1 differences are there versus how many 3 differences, and you multiply the numbers together. So let me just comment this out for a brief moment here. I know I've already probably lost people already, like, no, tell me the answer. You'll find it. But anyway, so I just print the data like this. You could see now I took that giant data set and I added a 0 and a max plus 3 because it says in the problem that you're starting from the wall with a 0 joltage, and then you're gonna, whatever the largest number in the set is, you're gonna add 3 to that to be able to handle on your device. So when I first did this, I screwed that up and I forgot about these last 2 parts, and I got the wrong answers twice. So I print out, so I go from 0 all the way up to 164 plus 3, 167. But all I'm doing is going through this list. I mean, it's very simple at the end of the day here, where I'm going ahead and I'm saying, okay, this is a 1 difference. This is a 1. This is a 1. This is a 1. This is a 3. This is a 3. This is a 1. And I'm just summing up. I'm just putting this into a list of the differences. Figure out what the difference is between the first element and the 0th element, and put that in there, and just accumulate the values inside of this list. And when I get there, take the number of differences that are 1 unit, take the number of differences that are 3 unit, multiply them together, and you get 2,272, which is the first part of this solution. I'm currently working on part 2, so I'll have that maybe for you in a moment here. Maybe not, we'll see. Okay, so this is part 2, and it's there. This is what I try to teach my students, that there's a right way, and then there's the right way. And sometimes a right way isn't good in all situations as the right way. So this is one of those totally, this is totally stumping me right now, but I think I have a solution, but I'm not going to be able to do it tonight. I'm going to think it over, mull it over, dream it over, and we'll see what happens in the morning. But this is my code. This will work if I have an infinite amount of time to wait to find the answer. Maybe a quantum computer, maybe not. I don't know if quantum could handle recursiveness like I've done. But basically, this will count every path. Let me start with the very simple sample data here and run this, and it'll come out with 8. And so coming back to the Advent of Code problem in part 2 here, he says, yep, for that data set, you'll get a number of 8. And for this data set here that goes from 28 to 3, you will get 19,208 or something like that. Yeah, I've seen that number enough already tonight. And so let me put that data in real fast and just prove that I save this, I run this, and I get 19,208. And so like the big hint is screaming right at you, and I knew it when I saw it. It was just a matter of, what can I do about this? And where does it come up here? It says there must be trillions of different, more than a trillion different valid ways to do this. And so like if there's 1900, 19,000, whatever, I'll take their word on it. What I'm going to do is run this thing overnight. I don't anticipate, the way these things go, I do not anticipate having an answer when I wake up, but why not have the computer run? I know that graph theory will bail me out of this one. It shouldn't take an infinite amount of time to figure the problem out. So I'm going to think about my graph theory. I'm reviewing it. I already have some things written down on paper. It's just been a while. how do you recursively backtrack and get a number of paths? Sure, that's a solved problem in the world, but I want to solve it myself. So but you can help me with some comments if you want to help me along. I'm going to bed for right now. I'll wake up and I'll post a new video if and when I get the solution to this problem. So thanks for sticking with this video. My first one of the year here that I can't solve in a reasonable amount of time before I go to bed, and just gonna have to call it. So thanks everybody. See you next time.